In this lecture, we'll implement a stack. In practice, you should just use the stack class that's available in the System Collections generic namespace, but implementing a stack ourselves gives us more programming and algorithm analysis practice. Our stack is of course a generic as usual, so we can store any data type in our stack. And the underlying structure that holds the contents of the stack is just our standard list from the System Collections generic namespace. So our constructor doesn't do anything. Our count property just tells us how many items are in the stack. And you'll notice there's no way to get the contents of the stack. The data structure enforces the fact that you can only get at the top of the stack. You can't sort of work your way down through the stack doing something. You can only see the top of the stack. For our methods, we can push onto the stack, and this is really easy. We just add something to the stack. Now the list add method adds the item we've provided to the end of the list, so we are thinking of the end of the list as the top of our stack. And you should go do an in-video quiz about pushing onto the stack. And the answer is, of course, it's perfectly fine to push onto an empty stack. That's how we get stuff onto the stack. We start with an empty stack, so pushing onto an empty stack is fine. We can also pop from the stack, which means take the top item from the stack. Now, if the stack is empty, then popping is not a valid thing to do. There's an empty stack, so you can't get the top of an empty stack. So we actually throw an exception here, an invalid operation exception that says you can't pop from an empty stack. But if the stack does have something in it, we first access the end of the list that holds the contents of the stack, and we save it. And then we call remove add on the list, which takes away that last item in the list, the top of the stack. And we need to do it with these two steps because the return type for the remove at method is void. So if we want access to that item, we need to save it before we take it out of the list. And then finally, we return that item. Given that, you should go do an in-video quiz about popping from the stack. And of course, you can't pop from an empty stack. That's a bad thing because there's no way to get that first element from the stack. The way peek works is we are looking at the top of the stack, but we are not actually removing the top of the stack. So again, if the stack is empty, there's nothing to peek at. So we throw an invalid operation exception saying you can't peek at an empty stack. Otherwise, we simply return the top of the stack. Notice we're not removing it from the list. We're just returning that item for the consumer of the class to do whatever they want to do with it. And you should do an in-video quiz about peeking at the top of the stack. And the answer is no, you're not allowed to peek at the top of an empty stack. And the last method in the class simply converts the stack to a string. Now you wouldn't typically let people do this because that does expose the entire contents of the stack, but it's certainly helpful if we're testing and making sure that the stack is working properly. And of course there is a test stack class that runs through a bunch of methods testing the stack to make sure it works properly. To recap, in this lecture we saw how to implement a stack, and we also saw how we can enforce the rule that consumers of the stack can only manipulate the top of the stack.